Xcel Energy operates 19,000 miles of high-voltage lines that cross mountains, deserts, plains, and wetlands, from the Southwest to the upper Midwest. This transmission system spans 10 states to bring our customers the safe, reliable electricity they depend on to power their homes and businesses. Today, thanks to significant investment, new technology, and a lot of hard work, Xcel Energy's transmission system is stronger than ever. The improvement began in 2010 when federal regulators issued a recommendation that every utility in the country verify and analyze their transmission lines to make sure that compliance requirements were being met and that changes hadn't occurred over time that could impact safe operations. Xcel Energy decided to go beyond mere compliance with regulations and use this as an opportunity to utilize state-of-the-art technologies to take operations to a new level.
We chose the most robust plan, which utilized a new type of survey technology called LiDAR.
The traditional approach of capturing data on the ground with field crews, survey crews, was not going to be time effective or cost effective. The LiDAR stands for light detection and ranging. It's a technology that we at Xcel Energy use off a helicopter where we have remote sensing capabilities. And that remote sensing is a laser that fires at the ground, and we're able to get a return from that laser and create a 3D model, a high definition model of what the right-of-way looked like.
LiDAR was able to survey 80 miles a day, whereas the most a ground crew could survey was 4 to 5 miles a day.
We're not even in the same ballpark from what we used to do. The cost is lower, the speed is faster, and the product is 100 times better.
We surveyed 100% of our transmission facilities across all 3 regions.
Some of these lines have been built in the last decade, but others went up half a century or more ago when designs were done with pencil and paper.
Back when it was all done by hand, there was allowance made for clearances. It would be greater in the design than they would be today. You design more if you really needed 24 feet, you'd maybe do 28 feet. Back then I used a pencil and a scale, triangle things. Now it's a mouse and a keyboard.
In the past, industry practice was to survey the center of a transmission line. Today, LiDAR captures 3D images of the full width of our right-of-way, plus surrounding terrain on both sides, vegetation, trees, buildings, even the air temperature, which can affect the sag of the lines. It's all important to make certain there is adequate clearance to assure public safety. Xcel Energy engineers realized they had a rare opportunity to leverage the 3D survey data.
To develop something useful going into the future that is more of an investment, we realized that by working with IT, we could develop smart models that would do much more.
Using a design tool called Powerline Systems Computer-Aided Design and Drafting, or PLS-CAD, Xcel engineers took the LiDAR data and wrote additional code to build an interactive, smart model of the entire transmission system. It will automate the complicated formulas that determine a line's rating, which tells us how much power a given line can carry under various conditions.
It's a really powerful tool for us to support compliance, to be more efficient, and to have a lot of rigor around the document control too. So from the system we'll be able to automatically generate the reports we need for compliance. We know that the data that underlies them is sound and the process is automated.
When fully operational, the new system will allow us to see the entire system virtually, much like the way Google Earth Maps work. Our engineers will be able to create and analyze multiple design solutions while working at their computer. We'll also be able to respond to emergencies and customer requests more quickly.
Storm and emergencies, if 10 miles of line go down in a tornado next week, we have the information at our fingertips to reorder those materials and give the crews all they need to replace them as quick as possible. Relocation projects, encroachment reviews. Typical encroachment request would be a developer wants to put a driveway or an access road for a new housing development underneath one of our lines, or a storm retention pond or things like that. So having this information makes us more nimble in both the engineering department and in the construction department.
I believe this does put us in a leadership position, primarily with just the quality of our geospatial data. Not all the utilities across the country have that.
It's an impressive byproduct, the relationships and the collaborations that we've built between the different offices.
I'm actually really proud of the work that we've been doing, just developing this new technology that didn't exist before.
Compliance and reliability, I think, are, hand in hand.
We're going to accomplish a lot of things over the next few years.